Okie dokie. My name is Stephen Huntington and I work for Southland Microscopes. The scope we're looking at here is a Swift M2251 corded microscope. It's a monocular with three objectives. 4 times, 10 times, 40 times. This has a 10-time eyepiece. This microscope magnifies at 10 times 40 is 400 times. 10 times 10 is 100 times. And 10 times 4 is 40 times. So at this magnification, it magnifies 40 times. Right? We use the microscope to look at very small things. Cells are the main use of a microscope. The cell is the smallest building block of all living things. Cells make up your plants and your bodies and your humans.
I feel like I'm in high school again.
Yes, you are. That is what a microscope is used for. It's a tool for learning, for developing, for solving. Many different industries use this for things. We're talking about cells in the biological department, meaning they're teaching it in education, right, botany, right, and healthcare. So they use this to look at blood in hospitals. They use it, right, a lot of biology. It also has different uses, which would be a different type of microscope in the electronics assembly area. Micro components in electronics are used at small, so there's a lot of soldering and a lot of assembly that takes place at a higher magnification. Those microscopes are 10 times 2, so they're 20 to 40 times magnification because you're dealing with something you can manipulate. This is going up to 400 times. They offer another microscope that goes up to 100 times, which is 1,000. That's usually what's going on. Let's move on. The microscope, the Swift M2251. This is the educational model microscope, high school, middle schools, simple basic education. There's 3 components in a microscope we want to pay attention. You have the optics, which are the glass lenses, which are configured at different angles and convex and all that stuff, all right, cross line, to be able to get what we're looking at bigger. So you have optics, which are the glass that lines through. The next we have on it are the mechanics. All right, we have a rack and pinion. All right, we have this is the coarse adjust. This is the fine adjust. That's the mechanics. It rotates both sides. The third component is the electrical. In the base we have lighting. Okay, so we have the circuit board in here, we have different bulbs to create the lighting. The lighting in conjunction with the optics, okay, is how we see it. Okay? So the way the light comes through the objectives is how clear we can see it. So it's the lighting through the objectives which is the design of the microscope. We don't need to worry about all that big stuff right now. Right now I'm going to service this microscope. So the first thing I do when I service a microscope is I plug it in and I make sure it turns on. I check the switch to make sure the switch covers properly. Okay? I wiggle the plug to make sure there's no short in the electrical in the plug here. I check to see here if there's any fraying in the cord here as it goes through. It's electrical. Okay? It works. What I want to do next is I want to see how well the microscope works. I need a slide. That's going to kill my video.